Hello everyone, and welcome to the 8th part of this MOOC dedicated to the fractionation section of the FCC. In the 7 first parts, we described how to get a fuel gas cut and several gasoline cuts. And we spoke about the fractionation of the LLCO, HLCO, and slurry cuts. We still have to talk about the properties and the future destination of each of these cuts. As a reminder, all the properties we will detail in these 2 last videos will be related to a typical VGO feed containing 0.9 weight% sulfur. First, the fuel gas stream recovered at the top of the secondary absorber will be washed with an amine solution to remove the H2S. This stream, as seen in previous videos, contains part of the 50% of the feed sulfur which has been converted into H2S in the FCC reactor. The typical H2S content in the fuel gas is about 2 to 3 volume% or about 4 to 6 weight%. But it might be a little higher in case we have injected some desox catalyst in the total catalyst inventory in the reaction section. Note that there is a MOOC dedicated to amine units in refineries, in which we can find all the technical explanations about the way how to remove H2S with an amine. Once the stream has been washed with an amine solution, the residual H2S content is about several dozen of ppm. Then, the final destination of this stream is the refinery's fuel gas network, and these molecules will be used as fuel in the furnaces of the plant. As far as LPG cut is concerned, it inevitably contains a little sulfur. Typically, this cut is also washed with an amine solution to meet the H2S content that must be undetectable in commercial LPG. Then, we typically use a sweetening treatment to remove the mercaptans. Mercaptans are hydrocarbon molecules linked to an atom of sulfur like methyl mercaptan or ethyl mercaptan. Note that commercial LPG total sulfur shall not exceed 50 ppm. That's why we need to remove the H2S, but also almost all of the mercaptan molecules. As an option, we can then separate the C3 molecules from the C4 molecules. Furthermore, propane can also be separated from propylene to produce a propylene-rich cut. This propylene-rich cut can then be routed to a petrochemical plant to produce polypropylene. Let's now move on to the gasoline cuts. Most of the time, the LCCS plus MCCS blend is known as light gasoline, and we can incorporate this blend into the gasoline pool. The distillation range of this blend is typically 15 to 160 degrees Celsius. Typically, the density of this blend is about 0.73, and it will typically contain 1% of the feed sulfur. That's about 300 to 500 weight ppm of sulfur. The molecules present in this blend are quite good from an octane point of view, since the run of the light gasoline is about 94. But the direct incorporation of this blend into the gasoline pool is not possible because of its sulfur content. That is why this light gasoline cut needs to be further hydrotreated to bring the sulfur down to an acceptable level compatible with the gasoline sulfur specification. But because of the fact that most of the sulfur is under mercaptan form in the LCCS, we often consider an extractive sweetening process to remove these mercaptans and then the sulfur. Indeed, in the LCCS, we want to maximize the mercaptans. These mercaptans can be removed in a sweetening process. Maximizing these mercaptans in the LCCS corresponds to consider a cut point between LCCS and MCCS of about 85 degrees C. Indeed, beyond 85 degrees C, the sulfur is also present under thiophenic form that is not able to be removed in a sweetening process. To remove this thiophenic sulfur, we need to consider a hydrotreatment step to remove the whole sulfur compounds. Note that the benzene content in the light gasoline is about 0.5 volume%. As a reminder, the maximum benzene content in commercial gasoline is 1% volume. So, no specific issue regarding this item. The typical distillation range of the heavy gasoline is about 160 to 220 degrees C. Then, its typical density is about 0.855. It contains about 2% of the FCC fit sulfur, which means a value of about 1,500 ppm. It is a very good candidate to be incorporated into the diesel pool, but after a hydrotreatment step to remove the sulfur. Well, that's it for this video, and see you for the last video to talk about the future of heavier cuts. In the meantime, do not forget to test your knowledge by answering the 5 questions of the quiz, and you can also get a certificate if you ask for it. See you very soon for the last video. Bye bye!